Hello, this time we are taking up a question on mixtures in which a solution is removed and then water is added and it is repeated couple of times. Such questions students find it tough, though in a course these questions are handled very well. The formulaic way, the logical way, how is it linked to percentages, as in compound interest also it is linked to, all those things are explained beautifully well. However, you should never get slotted to just one way. It depends upon the data that is given. So one of a very common way that is recommended here is to look at how does the total volume change, and the proportion of milk keeps changing in inversely proportional to the volume if water is added. But then just mugging that up is not going to help you too much. Yeah, you need to be versatile. You need to change your approach as per the data given. So this is a tough one. Try all this, give it a good shot, and only then you'll appreciate the way we solve it. And before I solve it here, a quick message. My CAT 24 batch is underway. Coming 2nd of May, I begin arithmetic. Till now I'm just doing number systems, so you can join till the 2nd of May without losing a lot. I intend to do number systems at the end again for those who join in after the original start date. Verbal 1 lecture is over. The next lecture is on the 1st of May. LR 2 lectures are over. You have recordings for all of them. And so joining till 1st of May, you don't really miss a lot of stuff. However, once arithmetic begins, then there's a continuous theme or a continuity which runs throughout arithmetic. So then it might get late if you join after that. If you're interested, the link is in the description. So now back to the question. So the uniqueness of this is that the volume removed is given in percentages. Okay, 25% is removed, 20% of this is removed, 50% is removed. Whereas the volume added, the water added is given in absolute terms, 24 liters and 48 liters, right? So the percentage is very easy to handle. So if I start with 100, the method is 25% removes, 75 it is. But the moment this is a relative, okay, and the moment you add a 12, you can't add a 12 to an assumed value. So you would have to take a variable, and when you add this 12 to this, then it gets a little tedious. The 75 will become 75V plus 12. And this is where tediousness begins. So I would ditch this method here, right? It's arithmetic. I should be doing it without a variable or so. So then how do I handle it? This time, we suggest that you work directly on the volume, that is on liters, and of what? Not of total. Yeah, just directly work that on milk and that of water. Now, how do I realize which one? Do this example and then see why this was easy and why the total need not have bought in, right? So, at start, I do not know the milk. In fact, that is what I want to find. So that's an X, and water is 0 liters. This is my start, right? Now 25% is removed. So when I remove 25%, it's essentially I'm going to be left. 75% will be left, right? So what is gone is gone. So 75% of this is 3/4 of X will be left, and water is anyway 0, right? Now I'm going to add 12 liters of water is added, right? So that water will directly get added here. The milk will not change. That's it. Once done. So just repeat it. It doesn't seem very difficult. The next time 20% is removed. So don't change anything. 20% is removed. And if 20% of milk will go away, 20% of water will go away, right? But I'm interested in what remains. So this is as good as 80% will be left behind. So 80% of this is nothing but 4/5. So 4/5 of this, I'll keep it in fractions only, 3/5x. And 4/5 of this, again instead of decimals, I'll just keep it in fractions. 12 4s are 48, 48/5, right? And then I'm going to add 24 liters of water. So this remains, the 24 liters is added, 5 into 24 is 120, 120, all oral students, 168/5. So second time also done. That's 1 left, and then the numbers are easy. 50% removed. So don't miss out that you have to work on left. 50% is left. So half of this is left. So that is nothing but 3 by 10 of x. Okay, half of this. Now you could divide 168 by 2, but since there's a 10 here, I'd prefer a 10 here. So half 5 into 2 is a 10. So this will be 168. And the last step is you are adding 48 liters of water. So when you add 48 liters of water, this will remain as it is. So let me write this once here, 3 by 10x and 48, that's 480. 480 and 160, 48 and 16 is 64. I know 640, 648. Do all calculations orally, students. And I've reached the end, and what's given that this ratio to me is nothing but 3:8. So the x, the unknown part is here. When you take the ratio, the 10 and 10, everything cancels out. So what do you have? Here you have the multiplication factor. 81. So you multiply this by 81. So 3 into 81. So this is 3 into 81. That simply means x is equal to 81. Or just do it your own ways. Yeah, just write the ratio is equal to 3 by 8. Solve for x, right? I think you can do it orally. And that's your answer. So you did not have anything. I don't count this really as a great variable or a tough something that made my life difficult, right? And then you need to analyze it further, students. See at what step, are you doing? You start, then you take 75% left, 80% left and 50% left. Then why do I need such a long way? Why do I spend so much of space? Can I not just finish it off with, oh, let me work on milk liters. Okay, and what is the milk liters? I start with x. Okay, x, and then what remains? 25% is gone, so 75% of it remains. When you add, nothing adds to this. And the next time what happens? 80% of it is left, 80%, and the next time what? 50% of it is left. So this is your milk. It's as easy as this. And what is 50% of 80%? Half of it, 40%. What is 75? 3/4. 3/4 of this, 30%. So that's a direct thing, student. The next step is you could have done all of it in one go if you could have just thought about it, right? So that is what we are saying is the successive percentage, linkages of this with successive percentage. So that's milk. So let's work on water, and this I know that I'm going to equate it to 3 by 8. That is given to me. This is equal to 3 by 8. So let's work on water. This time water, this 25% being removed does not act. So you'll start from here. Oh, that mixture has 12 liters of water. Okay, and now 20% of it is removed. So what is left behind is 80%. 80%, 4.8, or think in decimal. And now to this you're adding a 24 liters again. Okay, the 12. And of this complete thing now, then you are removing 50%. So that is half of it, 50% of it. And finally you're adding a 48 to it. Right, so this is the simple calculation with water. If you do this, you'll realize this is the exact same calculations. If you convert this to 4 by 5, 48 by 5, 120 and 48, 168 by 5, half of it 168 by 10, 480 plus 168, 648, 648 by 10. You will directly get your answer in very short space as well.